Video number 2 for chemistry revision will cover ions, ionic compounds and covalent compounds. An ion is an atom that has lost or gained electrons from their outer shell. They lose or gain electrons so that they can have a full outer shell. So the metals that are in groups 1, 2 and 3, they will always lose an electron to become more positively charged, because now they would have more protons than electrons. They always start with the same number of protons and electrons. And then if you've lost negative charges, you now have more positive charges. So that's why metals in group 1, 2 and 3 always become cations, which are positively charged. A non-metal gain electrons to make a full outer shell. So therefore they become a negatively charged atom. And this is called an anion. My little picture here, I've got a picture of a sodium atom. Hang on, I really wanted to use this thing. Picture of a sodium atom here. Sodium has an atomic number of 11, so he's got 11 electrons. He's got 1 electron in the outer shell, so he's going to lose that 1 electron to become a sodium ion with a positive charge. So it ends up looking like this. It's much easier to lose 1 electron than it is to gain 7. Why would you gain 7? Because 8 has a full outer shell. So instead, for sodium to get a full outer shell, he's just going to lose the outer one, and you move back 1 shell to the second shell here, which is already full. Here you have a chlorine atom. He's got an atomic number 17, so he's got 2 electrons in his first shell, 8 in his next shell, and 7 in his last shell. To get a full outer shell, he needs 8 electrons. So he's going to have to gain 1 electron. So if you have a look at this one, this is my chloride ion. He has a charge of negative, that means -1. And he has now 8 electrons in his outer shell. So where does he get that extra electron? He's going to get it from an atom that's going to lose an electron. And this is what happens when we get table salt, sodium chloride. Sodium is going to lose his single electron in the outer shell, so he gets a full outer shell in the second shell. So he loses that electron and he gives it to chlorine that needs an extra electron. So sodium becomes Na+, because he's now 1 more positive than he is negative. And chlorine, he gained that negative particle, that electron, so he's Cl-. Now, together these two attract. A positive and negative charge attract. Well, an ion is a positive atom or a negative atom. So, sodium chloride, 1 positive sodium atom for every 1 chloride negative atom, and you get an ionic bond. In an ionic bond you always have a metal and a non-metal. If you go back to your periodic table, everything in group 1 running down becomes a positive ion because they all have 1 electron in their outer shell. So every metal here becomes a plus ion. My group 2, they all have 2 electrons in their outer shell, so to become an ion, they're going to lose 2 electrons to become a 2+ ion. We're not going to look at these. Group 3 becomes a 3+ ion, every single atom in that row, in that column, sorry. Group 4 act like they've got a full shell, so they do not become an ion. Group 5, they gain 3 electrons in order to get 8. It's easier to gain 3 electrons than it is to lose 5 electrons. So these guys become 3 negative. They've now got 3 extra negative particles, so their charge is 3 negative. Group 6, they have 2 more electrons to make a full outer shell, so they become 2 negative. Group 7 simply become negative, we don't need to write the 1. And group 8, they already have a full outer shell, so they don't become ions. So once you know this, you can quickly use the periodic table to figure out what charge an ion will become. And don't forget, we always have a metal paired up with the non-metal when we have an ionic compound. These two will bond together because they have opposite charges and opposites attract. With your test, you guys are also going to get one of these, which is a valency table. It tells you the charge in which atoms are going to become. It also tells us some of the transition metals, so which makes things easier. Also, some of the polyatomic atoms, like this one here. So a polyatomic atom is a little bit different. You can see that this is NO3 negative. It's a nitrate ion. what it actually is a charged molecule instead of a charged atom, because I have nitrogen and oxygen combined already, and overall they have a negative charge. So two names for this. You've got a polyatomic atom, polyatomic ion, sorry, and a radical was the other name for it. Now, you guys are going to need to be able to turn a worded formula of an ionic compound into a chemical formula for an ionic compound. So here's some examples: silver sulfide, copper oxide, and aluminium oxide. Let's go for silver sulfide first. What you need to do is go to your valency table, have a look at silver. Silver is Ag+. Find oxide. Oxide is sulfide, wasn't it? Sulfide is S2 negative. So step 1, we write down our two ions, Ag positive and S2 negative. Step 2 is to write the symbols down without their charges. And then you swap the number only. Now, 1 is the same as 1 plus, and you put it down the bottom on the other side. Remember, swap and drop. Swap it and drop it down the bottom. So I take the number 2, I swap it over to my silver, and I drop it down the bottom. Now, we don't need to actually show the number 1. So my chemical formula for silver sulfide is Ag2S. Now I'm going to do copper oxide. So I go to my chart. Copper is Cu2 plus, oxide O2 negative. So I write down my symbols for my ions, Cu2 plus, O2 negative. Now this one's easy. If you ever see that you've got the same but opposite charges, so 2 plus, 2 minus, just like in math, this cancels itself out. So you can simply get rid of them, and the formula is CuO for copper oxide. Okay, my last one is aluminium oxide. So again, go to my valency chart. Aluminium is 3 plus, oxide is 2 negative. So I write down my formula for my ions, Al. 3 plus, O2 negative. Step 2, write down the symbols without their charges and swap and drop the number only. 3 goes to oxygen, 2 goes to aluminium. So Al2O3 is my formula. This means it takes 2 aluminium ions to cancel out 3 oxygen ions, and I would have a neutral molecule. Why does that work? Let's have a look at aluminium. Aluminium is a 3 plus. If I had 2 aluminium ions, that's a total of 6 positive. Oxygen is O2 negative. If I had 3 oxygen ions, the 2 minus, 2 minus, and 2 minus, that gives me 6 negative. 6 positives, 6 negatives if I have 2 aluminiums and 3 oxygen. It is a neutral molecule. Alright, now these ones are all examples that include a radical or a polyatomic ion. So you do the exact same steps as before, only we possibly need to use brackets now. So let's go to the first one. Sodium nitrate. I find sodium. Sodium's at Na+, and I find nitrate. Nitrate's at NO3-. Now the NO3, everything that's down the bottom, is included as the whole molecule. You cannot change it. You treat it like the symbol. So NO3 must be in your final product. So let's have a look. Sodium, Na+. Write down your symbols for your ions, Na+. Nitrate, NO3-. There's the symbol for this ion. Okay, step 2. You write down their symbols without their charges. Na is the symbol for sodium. NO3 is the symbol for nitrate. You can't change that. Now, remember before I said if you've got positive and negative, that means positive 1, negative 1. That's the same number. It simply cancels out. So we're done. Sodium nitrate, is NaNO3. Okay, so the next one is calcium hydroxide. Calcium is Ca2+, hydroxide is OH negative. So calcium, write down your symbols, Ca2+, hydroxide, OH negative. Step 2, write the symbols down without their charges. Alright, swap and drop time. Take the number swap it over to the other atom and drop it down the bottom. Take the charge here, the number is -1, we don't need to include ones. Now H2O is water, but I want 2 hydroxide atoms. So I cannot change the molecule, I need to just make more of it, so I use brackets. And Ca bracket OH2 is calcium hydroxide. Okay, the next one we've got iron carbonate. So iron, we're going to use the 2+. Notice that there's a 2 and a 3 there. That just tells you what the charge is, whether it's going to be a 2+ or a 3+. We're going to use the 2+. So, actually, let's use a 3+. We'll use the 3+. Iron 3+ and carbonate, which is CO3 with a 2-. So, write down your symbol. Iron, Fe3+. Carbonate, CO3 with a 2 negative charge. Write down the symbol without the charge. FeCO3, that must remain that 3 there, it doesn't change. Take the charge only and swap it over. Can't have 33 oxygen, so that's where we use brackets. Take the charge number only and swap it over, drop it down the bottom, must be down the bottom, Fe2. So what we've got here, Fe2 bracket CO3 close bracket 3. Now what this means is we have 2 iron atoms. Sorry for that, I had to just stop that midway. My housemate has just backed into a car, the car behind them. Anyway, so this means you've got 2 iron atoms, and you use this like brackets like in maths. There's 3 single carbons, so 3 carbon atoms, and 3 times 3, 9 oxygen atoms in the entire molecule. Okay, last one, ammonium sulfate. And if I look for ammonium, here it is, NH4+, sulfate, SO4, 2-. So I write down my symbols, NH4, charge of plus, and sulfate, SO4, charge of 2 negative. Step 2, I write just the symbol down. And I take the charge. If it's a 1, I can ignore it. I take the 2 here, swap and drop. Now I'm not going to have 42 hydrogen. It's impossible. I use my brackets. And it's going to be 2 ammonium molecules instead. So my formula is NH4 bracket 2 SO4. And you will have to realise that this means 2 nitrogen, 2 times 4, 8 hydrogen, 1 sulfur, 4 oxygen. And that is ammonium sulfate. All right, I'm going to give you guys a few examples, and you can pause it and work it out yourselves, see if you're understanding this. All right, so your examples are barium carbonate, magnesium sulfide, zinc hydrocarbonate. Forget that little gap there, I made a mistake. Aluminium iodide and ammonium carbonate. Pause it here and have a go on a piece of paper, and the answers will pop up once you press play. And there are your